afternoon, my YouTube viewers. In this video, we're going to do some more experimental design. And this experimental design that we're going to be working on is going to be factorial design. And so basically, we've got a practice question that we're going to go over. So the practice question is, test the durability or performance of new materials or devices under various conditions, using factorial designs to identify optimal configurations. And so basically how we're going to answer this question is we're going to write a program in Python. And in order to write the program in Python, we have to import some libraries first in order for Python to get in all the functions that it needs to execute the program. So we're going to import NumPy as NP, which is a numeric library that also produces NumPy arrays. We're going to import Pandas as PD, which is a data processing library that also creates data frames and series. And we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from itertools, we're going to import product. So itertools is a library that helps with iterations. And from scipy.stats, we're going to import f_oneway. So scipy is Python's scientific library, and stats is the statistical module within scipy. And f_oneway is the test that we're going to perform statistically. So after we have imported the libraries that we need, what we're going to do is we're going to set the seed. And the reason why you set the seed is so every time you execute the program, all of the variables will be initialized to the same values, and that way the program will run the same every time. So now we're going to define the factors and their levels. So temperatures is a list of low, medium, high. Pressures is a list of low, medium, high. Materials is a list of material A and material B. So now we're going to use itertools to generate all combinations of factors in our factorial design. So combinations equals list brackets, product brackets, temperatures, comma, pressures, comma, materials. So it's going to take that information and it's going to convert it to a list. So now we're going to simulate durability, e.g. lifespan in hours for each combination. So data is an empty list, and for temp, pressure, material in combinations, base durability equals 100. Temperature effect is a dictionary that has low equals 10, medium equals 0, high equals -15 temp. Pressure effect is a dictionary that has low equals 5, medium equals 0, high equals -10 pressure. And material effect equals a dictionary of material A equals 15 and material B equals 10 material. Variability equals np.random.normal bracket 0, 5. And so basically what's happening is you're creating a normal distribution with a mean of 0 and a standard deviation of 5. So total durability equals base durability plus temperature effect plus pressure effect plus material effect plus variability, and then data.append brackets, which is a list of temp, pressure, material, total durability. And so now what we've done is we're going to take the data and we're going to convert it to a data frame. So df equals pd.dataframe brackets data, comma, columns equals temperature, comma, pressure, comma, material, comma, durability. So what that means is column 0 is temperature, column 1 is pressure, column 2 is material, and column 3 is durability. So now you're going to calculate the mean performance for each combination. So summary equals df dot group by brackets, square brackets, temperature, comma, pressure, comma, material, square brackets, and then brackets, and then square brackets, durability, square brackets, dot mean, brackets, dot unstack. And now we're going to print the summary. So we're going to print mean durability by temperature and material. So we come over here to the bottom of the cell. And the mean durability by temperature and pressure gives you the material with material A and material B, and temperature, pressure. For high, it's high, low, medium. For low, it's high, low, medium pressure. And for medium, it's high, low, medium. And it gives you the figures for the material A, material B, and the temperature and the pressure. And so if you know about materials, then that would be good for you, you know. And now what we're going to do is we're going to perform an ANOVA to assess the impact of temperature on durability. So ANOVA results equals F one-way brackets, dF square brackets, dF temperature is equal to low square brackets durability, comma, dF square brackets, dF temperature is equal to medium square brackets durability, comma, dF square brackets, dF temperature is equal to high square brackets durability. And so now what we're going to do is we're going to print the ANOVA results for temperature impact, and we're going to print the F statistic and the p-value. So we come over here to the bottom of the cell, and the F statistic is 16.732, and the p-value is 0. So the p-value is going to be less than 0.05, which means the null hypothesis is going to be rejected, and the alternate hypothesis will be accepted. So the null hypothesis is there's no significant difference between the values, and the alternate hypothesis is there is a significant difference between the values. And so basically, the null hypothesis is rejected, the alternate hypothesis is accepted, so there is a significant difference between the values. So now we're going to visualize the data by creating a bar plot of the mean of durability. So plt.figure brackets fig size equals 6, 4. plt.subplot brackets 1, 2, 1. Temperature means equals df.group by brackets temperature square brackets durability dot mean. Temperature means dot plot brackets kind equals bar, comma, color equals blue, comma, orange equals green. So color equals blue, orange, green, excuse me. And then comma, alpha equals 0.7. And then the title is average durability by temperature. The X label is temperature. The Y label is durability hours. And the grid is axis equals Y, comma, line style equals dashes, comma, alpha equals 0.7. So now we're going to plot the mean durability by pressure. So plt.subplot bracket 1, 2, 2. Pressure means equals df.group by brackets pressure square brackets durability dot mean. brackets, pressure means dot plot, brackets, kind equals bar, color equals a list of purple, cyan, red, alpha equals 0.7. The title is average durability by pressure. The X label is pressure. The Y label is durability hours. The grid is axis equals Y, comment line style equals dashes, and alpha equals 0.7. So you have plt.type layout, plt.show, and here are the two graphs that have been created. So you've got the average durability by temperature and the average durability by pressure. So the best durability by temperature is going to be on the low temperature, and the best durability by pressure is going to be on the low pressure. And so the least amount of durability is high temperature and high pressure, and the medium durability is medium temperature and medium pressure. So that concludes this video. The next video, we're going to be talking about some more statistical subjects, so I hope that you decide to watch it.